I'm so thrilled to be here with you, Jensen. It's really an honor to get to learn from you. I wanted to take it back to the moment when you gained conviction around the deep learning. Do you remember when that was?
Very, very well. I learned about deep learning about the same time everybody else did, and maybe slightly before that. And it was because several pockets of researchers were simultaneously trying to submit for ImageNet, that big contest in 2012, and wanted two things: access to the latest GPU, which was the GeForce GTX 580. It just come out, and also learn how to program it, and for deep neural nets. And so we were fortunate to have learned about them a little earlier, but it was called neural network. And as you know, during that time, artificial intelligence wasn't very popular, and neural networks were suspicious and a questionable area of research. But nonetheless, we were helpful and we were the best we could. But the thing that really stood out for me was that how effective it was.
Yeah.
And of course, the next question when you see effective technology that's surprising is how would this scale? What other problems can it solve?
Yeah.
Because of the nature of the deep neural network and each one of the layers isolated from the other, and the backpropagation approach so effective, you could imagine scaling this tremendously.
Yeah.
And it turned out we were right. But the observation that we made was that deep learning was both an algorithm for solving problems that were difficult to specify. It was also a new method of developing software. Imagine you had a universal function approximator of any dimensionality.
Yeah.
And irrespective of the dimensionality and the size of the problem, so long as you have a large enough model, you could backprop it and learn it. And extrapolating that insight, I think, was really important for us. And we came to be very convinced of its potential. And because we realized that it was going to be a new way of developing software.
Yeah.
And since then, our Carpathy has called it Software 2.0. But we observed that it was a new way of doing software in the beginning, and realized that maybe we need to change computing altogether.
Yeah.
And since then, you could look back and realize that maybe for the very first time in 60 years, since the System 360 from IBM, that accelerated computing using GPUs and deep learning really reinvented computers.
Yeah.
That we might have discovered quantum computing before quantum computing, if you will.
Exactly.
And I think that was a really important moment. We were fortunate to have connected all the dots.
Exactly. Yeah, I remember reading the paper from Ilya and the folks and how they had started deploying it, and it was incredibly impressive because no one had really put GPUs to that use previously. But ever since, sort of the model architectures have started evolving a bit. Where do you think they're heading next? Back then it was the CNNs. We're now seeing increasing bets on multimodality. What makes you excited about that, and where do you think the model architectures are heading?
Well, let's see. Transformers and the work that researchers have done to reformulate just about every problem, every type of data into something that a transformer can learn. You could create a vision transformer. You could create a audio transformer. You could create, of course, a text transformer. You could create a transformer just about out of anything, it seems. And multimodality is really important for very, very clear reasons. They're higher performance. So, for example, if we're to say, you're trying to train a neural network for vision, and you've seen nothing but horses, and you've never seen zebras, But if you added another modality to it, like words, and you understood that a zebra is a horse with black and white stripes, somehow the combination of images of a horse and the words and the understanding of black and white stripes
exactly
combined allows you to imagine what a zebra is without ever having seen one. And so you've extended your performance. You could use multimodality to enhance the robustness of perception. So we do that for cameras and radars and LiDARs. We combine multiple sensor modalities so that we can extend the capabilities of your perception to encompass the superset of all of them.
Yeah.
You could also I guess enhance the capabilities with ambiguous things. Like, for example, if I were to say, "What is that?" The combination of my words and my gesture helps you understand what I meant. Hard to do that. Hard to do that with pronouns.
Exactly.
With words. And so multimodality is really important. And now we have the transformer model, and we've expressed transformers in a way to understand multimodality. And so I think that the next generation of AI models are going to be more performant, more safe, more robust, and do more things. I think it's going to be a big deal.
And I think what's really fascinating is just how much we've already been able to derive from language. That we've basically derived this world model from language that we can apply to very wide contexts. But you also speak about teaching these models physics. Do you think that's needed, or could we derive it as these models become multimodal? Will they be able to learn that from the training data as they get trained on video, for example?
Yeah, I think you can. Let's see. Just about you can imagine just about everything has been described in words.
Yeah.
Physics has been described in words. Newton's law has been described in words. So you could imagine that we can learn through the world's corpus of words just about all of the physical effects. If you've never seen the color red, it's really hard to imagine what red means.
Yeah.
But I wouldn't be surprised if there's enough poetry that describes the beauty of a red apple and how it compares to something else that's red, and the heart-shaped red emoji or something like that. And through all of those words, you've connected. Oh, this must be red. Through compare and contrast, and you must be able to learn that without having ever seen it. But I don't think you'll ever understand the sensation of something and the subtleties and the nuances of it without having the ability to combine all of these different things. I think it's possible to teach people the effects of physics, but if you wanted to predict the laws of physics, things that have physical phenomenon, you wanted to ground the AI in physics.
Yeah.
And it's no different than grounding large language models today using reinforcement learning human feedback.
Yeah.
In the future, you use reinforcement learning physical feedback.
Yeah.
And that physical feedback would instead of a human doing it, that physical feedback for a robot would be expressed in some kind of a physics simulation. And we created this system called Omniverse that obeys the laws of physics, so that we can give Omniverse essentially the digital twin of the robotic, the embodied robot, if you will.
Yeah.
And that embodied language model would then get reinforcement learning physical feedback, simulated physics feedback, digital twin feedback through Omniverse. And so I do think that you want to be grounded in physical truths for some types of robots. You want to be grounded in ethical truths, and that's alignment. One way of helping us create safer chatbots. So I think the two ideas are somewhat parallel, and it's somewhat sensible, and I think it's going to be helpful.
Yeah, that's probably how we all ended up in this simulation. It was you started doing these experiments.
Exactly.
Where do you think the cap goes? Do you think we can keep running with the existing model architectures, evolve them slightly, scale compute, or will we need radical breakthroughs and see diminishing returns quite soon?
I think, first of all, I don't know the science behind it, but the intuition would suggest that there are many aspects of our intelligence where we apply rules, and rules that are either learned, rules that are expressed.
Yeah.
There are many principles and rules in our company, in particular society, in particular cultures, that are expressed simply through words. You didn't learn it into existence.
Yeah.
Thou shalt not kill was not one of those things that we learned by trying everything until we discovered that thou shalt not kill. We were just, we just learned it. Yeah. We were given that rule, and so there are many rules that can be expressed without having it be learned. And I think there's that form of symbolic reasoning that could augment these learned, exhaustively learned models. And so there's, I don't know what the science is behind it, and whether it suggests one way or the other way, but it seems intuitive that we augment our intelligence through things that are learned through reinforcement learning, and things that are learned through experience, things that are learned through just because that's the way it is.
Yeah. One thing we're so excited about at Sana is really this possibility to augment the human intellect now as well. If we could provide researchers with the tools to run thousands of parallel experiments and get augmented by this rather than replace it, how do you view the role of humans in this over time? Once we reach a point where this is orders of magnitude more intelligent than humans, what role do I have to play anymore?
I don't know. I don't know, but I'm surrounded by people who are orders of magnitude more intelligent than I am in certain skills.
Yeah.
And I have no trouble coexisting among them. And so I am already living in an environment where I'm surrounded by super intelligence.
Yeah.
Relative to myself, I feel like they're able to do things that I can't imagine doing.
Yeah.
And somehow I exist, quite harmoniously within it. I do think that we are going to elevate basic intelligence. We've elevated many things that over time has commoditized a very, very important human resource. We democratized the hunting of food by farming. We didn't have to, run after or be chased after by food.
Yeah.
We democratized, of course, the production of power, and so, people who are smaller and weaker can live in a world where things are rather heavy, and so you don't have to be just gigantic and muscular to exist in that environment, and we democratized the access of energy, and as a result, society elevated in its capabilities, and I think that we're now democratizing intelligence, the production of intelligence, and but I think value will still go to people who have deep domain expertise, some incredible passion, which is now elevated, as you mentioned, through the ability to try all of these future scenarios so that we can amplify our own passion and our own expertise. The other dimension of it, which I'm hopeful for, is that for the last 40 years of my career, the vast majority of population has not learned how to use this instrument that we call the computer.
Yeah.
Only a handful, and I think you started learning how to program the computer when you were early teens.
Yeah.
And for the vast majority of the world, They don't know BASIC. They don't know Python. They don't know Pascal or Fortran or C or C++ or Java. Or, they don't know how to program these computers. And even though it's very sensible to a small population of the world, call it 1 million or so, the billions of people have no clue how to do this until now. And now with ChatGPT, as you know, the programming language of choice is human. And you could program it in Swedish, and I can program it in English, and you can program it to write a program to program another computer. And so we democratized programming for the very first time in history. And I can't help but believe that that's going to empower billions of people who currently see this instrument of value creation and this instrument of productivity, this incredible light speed traveling machine that we sit on called a computer. For the first time, everybody can have access to that. And so I'm hoping that it's going to bridge the digital divide. I think you could make a case for that. And you're seeing it happening right now in real time with kids on the internet prompting these machines, writing amazing programs, generating beautiful images, and they're just kids. They didn't know how to write a program, but they could do this. So
I think that's really fascinating as well with how you're accelerating compute at NVIDIA, because you're using AI yourselves to develop more advanced compute. Could you tell me what that cycle looks like?
Well, our current generation of chips are so large and so complex, all the employees in our company can't possibly design it. And so we use AIs to help us explore the design space. And as you said, experiment with hundreds of thousands of permutations of the design and find us the one that has the best trade-offs.
Exactly.
And the best trade-offs are trade-offs that we determine. There is no perfect optimization. There's just an optimization that's best on some trade-off. And sometimes we might want to trade it off on speed at all expense. And the reason for that is it's the critical path. And you want to make that critical path absolutely as fast as possible. Maybe it's because it's something that you have to instantiate thousands of times, and now energy efficiency is really important, so you optimize for energy efficiency. And so we make those kind of judgments, and then we set the AI free to go and discover all these corner conditions and all these different permutations for us, and it comes back with a design that no human can do. And that's really quite amazing, that we're looking at these designs that we've put into the latest generation Hopper that no human has ever designed before. And it's that incredible. And so, or it's because we have to connect thousands of modules on a chip, and the combinatorial explosion of thousands of combinations is more than all the atoms in the universe. And so only an AI could figure out what is the best optimization for that.
One other question I was really intrigued by your perspective on is, how should we think about defensibility? Last time we spoke a bit about the value of domain expertise and really integrating yourself deeply into workflows. But for companies executing on the application layer, how should they think about defensibility as these models become increasingly commoditized? They're able to learn from smaller and smaller amounts of data. A lot of the historical moats don't seem to apply anymore. How should we think about building a defensible business?
Mm-hmm. Well, I don't know that there's any evidence that understanding a domain of problems or understanding a segment of customers has ever lost its value. Our technology, the world's computing technology, and the number of well-educated people obviously growing. The new college grads that are coming out of universities these days are really quite amazing. Just about every single one of them were smarter than we were when we first graduated. And the type of problems they can tackle just from graduating from school were the type of things that entire companies used to do. And yet there's every every evidence would suggest that understanding deeply your customers' challenges and is really quite valuable. And so I think that's not going to go away. We're going to have incredible basic AI capabilities, and it could do amazing things. It could solve all the hardest math problems, and it'll pass bar exams, and yet we know very well that somebody who's passed a bar exam, when brought into a domain of a particular issue, still has to learn about the fundamentals of that industry, and what is the problem that needs to be solved, what are the complex relationships between people. Oftentimes customers are people, and they have complicated challenges that they're trying to solve themselves. And so understanding people, understanding the context, and oftentimes those things are poorly expressed. And so those are social science problems.
And what are you most excited about on the application layer?
Well, for us, there are three. I would say that if I can categorize it into three things. What are the things that AI can do that can enhance, revolutionize the work that we do to build our products? So that's one. And we were just talking about one. The way that we design chips has completely changed. The second, the way that we design software has changed. The second, of course, is what are the things that AI can now enable us to do so that our products are different? Yeah. Revolutionizing not just the way we design our products, but revolutionizing the products that we build. So, for example, there are many gamers in the world, and the way that we used to build a graphics card, we would design programmable shaders, and of course there's compilers and things like that. But that's it. We ship it, and we ship a great processor with great compilers, and we integrate them with games and such. But now you can't even ship a GeForce by itself, because there's a supercomputer in the back learning how to make predictions of the missing pixels, because we have to denoise and we have to infer pixels. We infer about out of every one pixel that we render, we now infer somewhere between 8 to 16 pixels. I mean, it's like getting a jigsaw puzzle where you're giving one piece and you're supposed to guess the other 16. Yeah. And so we taught an AI. We have a supercomputer in the background just learning how to do that and improving the algorithm, and then we download the algorithms whenever we improve it. Yeah. And so now we use AI to revolutionize not just the way we design that GPU, but the way that the GPU even produces the images. And so it helps us create much more energy efficient processors that exceeds any capabilities that Moore's law would have predicted. And then the other thing the third category I would say is where your world is, which is to turn the whole company into an AI. Yeah. And so that all of our employees are augmented by this, system that is running all the time. Yeah. And so that we're not searching for information that we'll never find. So that maybe we can connect dots and predict opportunities in a marketplace, or maybe the supply chain has changed, or maybe the market demand has changed, and it's impossible for us to see all the signals, but it's not impossible for an AI to see all the signals. Yeah. And so over time, from the way that the employees work with each other, the way we learn about the information that we need to use, to the way that we forecast demand and work with our supply chain, all of that is going to be revolutionized by AI.
And what do you think is your most contrarian view on AI right now?
I don't know that I have anything that's particularly contrarian, because if you look at the world today, most of the conversations about AI are either beyond enthusiasm for its promise and beyond concern of its perils. So somewhere between the extreme conditions of promise and peril, which is being discussed in real time all the time, probably is the truth. And there's no question that technology of this capability, and throughout history, technology of any capability has brought enormous transformations and discontinuities in society and economy. And so there's a fair amount of peril that we have to consider.
Yeah.
The type of, who would have thought that there would be a whole bunch of people who are doing web designers?
Yeah.
You know, this is a profession that didn't exist, or programmatic ads.
Yeah.
These are professions that didn't exist when I came out of school 40 years ago.
Yeah.
But they're entire industries today. And so somehow this enabling technology called the internet has recommender systems. The early versions of AI has made it possible for us to create this new industry. I think that we're going to have to reskill, retrain, and so that jobs that are dislocated could be transformed. But I'm certain that there will be brand new industries that are created that we never thought of. Like, for example, right now we are seeing this coming alive in real time is prompt engineering.
Yeah, exactly.
Right?
Yeah.
Prompt engineering is like, it's going to be a real thing. It's going to be a giant industry. It could be the most important programming industry.
Exactly.
And so how many people are going to be prompt engineers? It's incredible. You're seeing AIs that are helping write prompts, right? To prompt other AIs.
Very meta.
It's very meta indeed, yeah. And so I think we're going to see all of that. And so I think there are a lot of good things that are being discussed. I love the conversation around safety.
Yeah.
We have to dedicate as much in technology investment in the capabilities of AI as well as the safety of AI.
Yeah.
You know, we happen to work in the field of self-driving cars, and we probably have just as much resources dedicated to making the AI safe and the car safe as we do making a drive. And so I think large language models will have to do the same, and the technologies associated with building AIs for guardrails so that you keep it in the operating domain, to technologies related to alignment, reinforcement learning, human feedback, which is like reinforcement learning with physical feedback that we were talking about earlier, to technologies of vector databases that reduces the ability or reduces hallucination, so you augment it with facts.
Yeah.
All of those capabilities, I think we're going to see just an explosion of new ideas to transform that core large language model, surround it with other AI technology and methodologies and best practices. All of that is going to turn that large language model into usable chatbots.
Exactly.